So the first part of this question is asking us to explain, because of the star, why the angle BCD, so BCD, this angle here, we're having to say why is it 90 degrees. Well, it's a shape involving a circle and a triangle that is bounded by a diameter dB, where the triangle vertices are all on the circumference. So it links to circle theorems and the idea that the angle in the semicircle is 90 degrees. So literally here, though, we'd have to say something like angle in a semicircle at the circumference is 90 degrees. Okay, I mean there's lots of ways of saying this. You could say the angle subtended from a diameter, the circumference is always 90 degrees. Lots of different ways of saying the same thing. The question then goes on to calculate the length of BC. So BC is here. Now we know this is 90 degrees, we've got an angle, it pretty much is shouting out to use the trigonometric ratios sine, cosine or tangent, and therefore we'll need to have another length somewhere to work out the other length knowing an angle. So we look at the triangle here and we can see that the length of BO is a radius, so if I work out the answer for BO and double it, I'll have the answer then for the whole of BD, which will then give me enough information to calculate BC. So this triangle here, we can see that this angle here, we'll call it theta, is allowing us with this length here to work out the length of OB. So if we remember our mnemonic, and there's lots of ways of doing these ratios, but lots of people learn it through SOHCAHTOA, and so if we label up our triangle, then we've got the opposite length there, and we've got the hypotenuse length there, and although we label A, we know we don't actually need it because we have to find the length here knowing the length there and the angle theta. So we've got O and H, so we were able to think about those two lengths, and therefore we can use the sine function. So we should write out the full function. So the sine of theta is equal to the ratio of the two lengths, the opposite lengths divided by the hypotenuse length. And if we go through identifying the information we know, so we know theta is 35 degrees, O is what we're trying to find, and H has been given to us 7 centimeters. So we place everything we have in here, and so we have the sine of 35 degrees equal to O over 7. We want the length of O, so we're going to say O equals 7 times the sine of 35 degrees. So that is going to be, and we check our calculators working in degrees mode, which this one isn't at the moment. So we go through pressing our appropriate function to make sure it's got D or deg there in the screen, and we then do our calculation. So 7 times the sine of 35 equals, now this isn't the final answer, so we better write down at least 4 significant figures, as the answer wants to be to 3. So let's go a little bit further than 4, so we'll just write down that, and so the 5 as well. So we know that the length of OB, so this is the length of OB. We know the triangle we want to deal with to get the final answer for BC is this one here, and we've just worked out the length of OB, so we're going to double it to get the length of BD. So BD equals, well, if we double that, times by 2 equals 8.03007. So that'll be accurate enough for this work because we've gone past 3 significant figures and the question's working in centimetres, so write our units down. So we now know then that we've got the triangle that we want to work with. We knew this was 70 degrees, we know there's the right angle. We've now worked out this length here, which was the radius of the circle, the diameter of the circle, so this is the 8.03007, and the length I wanted was this bottom one, so that's the question mark. So we go through, again, if we think about SOHCAHTOA, it's about a right angle triangle with lengths and angles, so SOHCAHTOA. There's our theta, so this will be our opposite side, this will be our adjacent side, and this will be our hypotenuse. So we've managed to work with the adjacent length and the hypotenuse length, need the adjacent length, know the hypotenuse length. So we're using the cosine ratio. So we write that down. So cos theta equals A over H. We know theta is 70 degrees, we know A is our question mark, and we know H is worth 8.03007. So we fill in what we know. So we have for the cos of 70 degrees is equal to A, what we need, divided by 8.03007. Rearrange, so this comes across by timesing. So A, the length of A is equal to 8.03007 times the cos of 70 degrees. So we left that in our calculator, so we can do times the cosine of 70 degrees equals, so 2.75, so 2.7464. But three significant figures, we're going to write down 2.75 centimetres. So that's a recap of using SOHCAHTOA trigonometric ratios to allow us to find missing lengths within triangles involving an angle and one length to find a missing side length. And in doing that, we ended up using these ratios to find the final answers for this question was 2.75.